Welcome to my second lab, Motion of a Falling Object. This is an analysis of a falling object and the forces that act on it. So, before we begin, we'll see that gravity and drag affect falling objects the most, and I'll illustrate this in a series of steps, first through tracker, then through my computational models, then my graphs, and then more computational models to illustrate the concept of terminal velocity. So here's my tracker video. It's a piece of paper falling from a height, and as you can see on the side, there is a slight downward curving trend to the graph, and there are a couple distortions because my camera wasn't straight and also my camera's frame rate wasn't necessarily exactly smooth, so there are a couple of repeated position instances. Okay, so now let me show you my computational models. Here's the first one without drag. So I'm going to run it. And as we can see, the graph has a slightly downwards trend and the net forces are in the downward direction. Next we'll see the computational model with some drag, and I think my drag value was somewhere around around 0.003, and as you can see there will be a blue arrow appearing. It's just my computer is a little slow, and the final position is a little bit less than the model without drag. So now we'll look at the graphs. And as you can see, the red line, which is the non-draggy one, has a downward trend. The draggy one has a downward trend also, which is the yellow, and the blue one closely resembles it. So it's a fairly accurate experimental model, just a couple of experimental errors that weigh it down a little bit. And now finally we'll answer the what if questions. The first question, I believe, is something along the lines of velocity versus time and showing terminal velocity. So I've constructed a model that runs for a bit longer than my model because my experiment never reached terminal velocity, and so it starts out, and there you can see there the change between the different values is really significant, and I've skipped ahead here because it's just a little drab. As you can see, the slope of the line is getting closer and closer to being straighter, which means that it's approaching terminal velocity, and I think terminal velocity for this is around 7.7, negative 7.7, but yeah, and as you can see, the values of velocity are getting slower and slower. I had it printed to my console, sorry. And then we have another model where that illustrates the second question, the initial velocity, throwing it down, does it change the terminal velocity? And I've changed the initial velocity vector to be -4, the y component to be -4 rather than -1, and we'll see what happens right now. And I've also skipped a little bit ahead to illustrate this a bit quicker, because otherwise I'd go over time. And so as we can see, the velocity values get slower and slower, and so it does not matter if the initial velocity is less. So now we're going to explain the physics behind the data. Sorry for my slow typing, but there are a couple of different things happening. There's the gravitational force that is acting on it, and the y component for the net force without the drag would be just the gravitational constant times the ball's mass. And so depending on whether your constant is -9.8 or 9.8, you'll have an F net of gravitational constant times the ball's mass, and that'll be the y component of the vector. Sorry, I'm a slow typer. You'll see this coming up, but it should be noted that I didn't say that it was a vector. I just gave you the computer code, but this is the y component of the vector. And Yep, and then moving on from that, the drag counteracts the net force, and so it yields a new net force when it is combined with the gravitational force. The drag slows the rate of falling, so that's how you get terminal velocity. Else, in a system where there's no drag force or opposing force or reciprocal force, that's a vocab word, the system will keep going on and on and on, and they'll never reach a terminal velocity. The velocity will constantly increase, so you need some counteracting force. And I'm just typing that here. And if you have questions, feel free to contact me. I believe my username is legmonkey, and my name is Rovan Bhargav. So with that, I want to end, and I thank you for watching this video. So yeah, here's the questions, and thank you.